AI. We are still having a AI which is working in a weak AI mode. So kind of problem that we are thinking from the first at the beginning, that is a bigger problem. But ultimately we have to narrow down the problem to a narrow, as much as narrow you can bring it, then better systems you can make it. So a lot more about that we are going to discuss in this particular session. But before I can start, I'll give you some thoughtful information about AI. What is basically an AI and what kind of steps involves to make AI systems more intelligent. So artificial intelligence is basically a field of computer science, and it is dedicatedly used to solve the problems which otherwise required human intelligence. So there are lot many problems, kind of problems where human intelligence is required to a certain extent. But even we have a problems where the task is repetitive. We don't want to involve a human resources for a task which is repetitive and he's doing again and again the same kind of task. Like we built some kind of robots for that to do that task. But we want to make intelligent robots. We want to make intelligent machines so that they can perform the task more than better like human can do. But only the problem is that we are not entered into the era of strong AI, where we are talking about artificial general intelligence. So human has a general intelligence. How human can see a problem and how he can have a different kind of approaches. So if you can see from the evolution of human intelligence, we have now kind of problems and we have kind of strategies to solve and conquer those problems. Begin from very basic. We have a problem, then we look on the problem prospects, how the problem is look like. Whether a problem is very big, then we have a strategy to divide the problem into a small problems and try to conquer a small problem at first, and then all the problem that we have solved in the small problems, their solution collectively we can take it together. So kind of strategy is like that. Likewise, we have also kind of strategy of greedy approaches. There we can think like a greedy person to solve a problem. So problem has a variety. Now we have to stick to a one specific narrow down problem and take it the approach which is more feasible and more appropriate for a machine to be trained on. Okay. So we are entered in an era of initially in a weak AI. So all the kind of equipments that you are seeing in the market, like Alexa is there, Google Assistant is there. They all are an example of weak AI. And some of the industries are also focusing on the strong AIs like Google, Apple. These are the companies, they are also trying to make a robot like they have an intelligence similar to like human, general intelligence. But that easily will take a decade to reach up to that stage. So strong AI is not yet built up in practical, but weak AI systems are a lot we have seen in our day-to-day life also. When we browse internet and kind of like purchasing something from Amazon, then the helping hand chatbot is there who is helping us to take certain decisions. Beyond that, we have recommender systems, like if we are purchasing some product, then how this product is related to other products. So some suggestions will came up, and we sometimes forget that this thing is also essential. Yeah, I wanted to take that also. So kind of systems you can build it to weak AI, but still the weak AI can also give a kind of problems. It is not a effective systems which can take all the decisions by itself. Sometimes the chatbot is itself confused when the person is writing some kind of text, which chatbot is not trained for that. So in that case, the human assistance is required. So there are kind of problems where the weak AI is also not up to the mark. But we are entering into this particular weak AI era, and soon we are going to have a better systems also. So some applications of AI, if you can see, like we can have expert system, we can have a natural language processing systems, we have speech recognition systems, and machine visions. So these are the dominating area where AI is at present entered into this particular area. But we can also build a kind of AI systems which can solve our day-to-day lives, like solving some problems which might be repetitive for someone. If I can give you an example, kind of lab testing, pathology lab testing, a person takes a sample from the patient and he will analyze the blood samples and finding out the certain parameters from the bloods. So this is a kind of job which is repetitive. So why can't we allocate these kind of jobs to a machine? So machine will take a sample and analyze and generate a report. So kind of systems where we have a day-to-day spending of much resources, and that is not going to give us a kind of benefits, then we can have these kind of solutions. So reaching the point of string AI could take easily a decade. So we are not yet entered into that era. And now if you can see, this particular diagram is basically talks about the artificial intelligence. So artificial intelligence is the top of the topic, and we are talking about within that artificial intelligence theories and technologies. So, but if you can see, the core component of an AI is machine learning and deep learning. So machine learning is an intermediate level, entry level, where we are going to train a machine with some set of data, and data we are going to cleanse it and clean it in such a way that the machine can fix its goal and it can reach out to that goal easily. So machine learning algorithms are going to train your machine for a specific task which you are going to choose. Deep learning is a kind of model where we are talking about artificial neural networks. Like our human brain will have biological neurons. So complex neurological structures are there in our body which keeps a memory of informations. So kind of deep learning is a model where we are trying to mimic the human biological brain with kind of machines. So we are going to discuss about that also with some kind of practical sessions. So in this particular session, I'll be going to talk about all the life cycles of AI. Along with that, I'll give you a small demos so that you can correlate what I'm talking. So initially, the question comes to our mind, how we can spot an AI. So there is a huge digital market is there. Huge number of products are there. How we can identify an AI system is this one, and this particular thing is not having the AI component. So if I can say in more generalized way, data science engineers or machine learning engineers, they can easily predict that this is what the kind of AI system, this is a kind of traditional programming control systems. So when you enter into the AI systems, you are going to have a kind of programming languages. So AI is mostly referred like a machine learning algorithms. So it is not like we are talking in generalized way. The AI is basically talking about theories and technologies, but the core component is machine learning, where the actual scenario is going to take place, where intelligence part of the machine can come. So if I wanted to make a difference between an AI and the traditional systems, then there is a kind of difference. Like in traditional programming or traditional program or traditional systems will have a set of rules that is defined in the programming context. Like if I talk about the C programming languages, it has its own structure, it has own its data types, different types of functions. So I will be having a set of rules. Beyond that set of rules, I'm not going. I'm always be taking those rules and writing my programs and solving some kind of problems. So I'm not just talking about the programming language context. Like even if you have done HTML coding, like a small HTML page you have created, there also you have a programmatical syntax, and within that you have a various HTML tag that you are keeping into the program. And when the computer start reading those rules that you have written in the program, he can understand this is what the user is interested to look at. So the computer will solve those programs with the predefined rules that is already there in the system. That is kind of traditional machines will do the task. But when we are talking about the machine learning or AI systems, They have a kind of programs or kind of algorithm which makes their rules by their own. Only the thing that requires the machine is the input data and one particular goal. Like I have a goal and I wanted to reach to that goal. So what are the different approaches I can have? If you can take a general example, I wanted to go from Chennai to Delhi. So I can have a various options to reach at the Delhi. I can go by bus. I can go by my own car. I can go by flight. So there are different options. But which one is the best one? That we wanted to learn by our experiences. If we have the previous history of our journey, we have encountered some kind of problems by that time of journey. When we did through bus, we encounter some kind of problems, headache and a lot of tiredness. Then we find out that the flight journey is quite a good, but the money wise it is not a promising one. So how we can take up our decisions based on the previous experiences, and these experiences comes from the data. So we are going to provide a data to a machine, and machine is going to learn from that data and trying to make their own rules and reaching out to that goal. So initially, if I can talk about a machine like a brain child, it is not having that kind of intelligence to make up their decisions with the available set of data. It has to learn from the experiences. Like when a newborn baby comes into the life, we are going to give the lot of information to that child, and he also look around with the environment, what kind of the informations are revolving around it, and he will start learning the things. And then sometimes he will may face a problem, sometimes he will be going to make it correct by experiencing those failures. So machine learning will do also the same. At the beginning, with the available data, it is going to make a decision which is not quite a correct. But once you train the machine again and again, so 100 or 200 or thousands of trials, when you keep it on the machine will start taking a quite a good guess or quite a good accuracy of results. So this is the diagram will basically represent that. So in traditional programming or traditional programming based computer systems, you have an input, you have an output, and within that you have a processing unit. So this is what the way the traditional system work, where the input is there, output is there. But when I talk about the machine learning, then you have an input, and there is a model that you are going to build where the machine is going to learn from the past experience data and making out the correct decisions that is going to lead to the goal. So machine learning or AI systems are basically quite the same, and they are basically needing a input data and one target to reach out to that. That is why I'm telling we are not in the era of strong AI system. We are entered into the era of weak AI. We need a small goal, and to reach out to that goal, some kind of data. So now you can easily make up kind of what is the life cycle is going to need in order to make a machine. Initially, we need a problem. That problem we wanted to fix in a narrow way so that the machine can achieve their goal more effectively with set of data or past experiences. So that data, we are now going to look into the data's perspective. What is going to give the data to us? So what data is going to tell us? So some statistical measures that we are going to see inside the data and how the data is look like. So all I'll be going to discuss one by one. Now, before I can start, let me give you an idea about AI learning strategy, how AI is basically evolved with a kind of good guess or kind of correct solutions for a problem. So AI basically start like a blank slate. There is nothing written on that blank memory, knowing nothing about the problem. So he is also not knowing this is what the problem I wanted to solve and this is what my goal. So how I can achieve that goal. So that kind of knowledge is also not there. So why this is like a blank slate? Because AI is a kind of system where memory is not there. AI is not like a, I must say, not very good in remembering the things. So memory side, we have some other models, but If I can say a general AI system will not have a memories to remember the things. So AI is very weak in remembering the things. So how is going to make a decisions when there is a problem, there is a goal, how AI is going to learn out of that. So AI is mostly a basic, all AI needs its goal and set of data for learning. So AI basically do the trial and error. So AI learning process goes like a trial and error. It tries and it fails. It tries in it again fails. And every time when it fails, it find out what is the consequence of that. So it is going to adjust again in the new step. This is what the adjustment I'm going to do. Now let's see whether I am able to reach to my goal. If is able to reach at its goal, then it's a quite a good trial and error methods. So AI trial and error invent new rules that will help it to reach its goal. Okay. So AI tries to reach its goal. It can discover rules and correlate that program did not even know existed. So like a kind of problem, if I can give you so that you can map it with clearly what this statement is going to say. Like when you play a chess. So chess board, if you can see 8x8 kind of blocks are there and you are placing your uh, items over there. And now the AI will have the kind of strategy like trial and error. So it is going to play around with itself. First few trials it will do by himself. So opponent is also computer and he is also computer. He is going to see all kind of possible moves. When the situation occurs like that, which possible moves going to lead me to the win. So likewise, it will play around with all possible moves. And then when the grandmaster comes and play with the computer, sometimes computer beats to the grandmaster also. Because when we are thinking, we have a not a broader dimension of thinking. We are only can see at the three dimensions and we can have that kind of thinking capabilities. But computer can have a broader dimensions. He can even think of more than a human intelligence, but he's not thinking. I must say it is searching. Search space is more as compared to the human. So the computer will identify the all possible moves. Even the opponent will not know that this kind of move can also be possible. So during the play he may miss out one kind of move that computer will know about that move also. So sometimes the chessboard games you have seen, the AI is basically dealing and reaching to its goal in more effective way, and sometimes it leads to the grandmasters. Okay, so programming an AI is almost like a teaching a child than programming a computer. So imagine a context where you have a real world scenarios and then you try to map it with the real world to digital world. How you are going to train a computer. So sometimes AI is only a small part of program, while rest of it is rule-based scripting. So basically, rule is going to make AI decisions reaching out to the goal. So rule-based programming is basically an important concept, and AI rule how it is going to make that programmer even not knowing about that. That's a problem. So sometimes that bad rules makes bad decisions, and the in past AI based Microsoft image recognition product was launched into the market, and it was trained with lot many images. So it was quite a good with some kind of images, and it is going to capture the images and giving the description about the images. Like caption, it was adding the caption about the image. So if one child is making some diagram, he can correctly caption that particular image. But the bad rule comes when you are not giving the kind of training that the AI system is looking for. Because AI captioning of an image is a broader problem. It is not like a kind of problem which follows all kind of understandings. Like if I can say the bad rule, what is the consequence of bad rule? Like if you can see, this is what the image shown to the Microsoft image recognition product, and it has to label it like a herd of sheep grazing on the lush green landscape. So this is what the actual image, if I wanted to train my Microsoft. So this is what the actual image Microsoft has used to train its model. When the same scenario was occurred like a green lush land, but there is no kind of shifts. So in that case, what happened? Even though Microsoft image recognition system trained with this kind of data, that is correct, but the AI model learned from the green lush lands. It has not learned from the ship also there in this particular picture. So when I have shown with empty this particular green landscape, then Microsoft is labeling it with the ship also, because ships are not there, even though is doing that kind of crazy goal achievement. So this is what the bad rules is going to lead you to the bad classification to a problem. So this is what we have to first narrow down our problem and fix our goal, and we can find out there is any other ways around the model can predict. That also you have to look on. So if I can say image based, image can be of variety type. Sometimes you have even seen a goat. Goat is normally grazing on the ground, but sometimes it climbs to the tree also. So if I can show that image to Microsoft image recognition product, it will show me the giraffe. Giraffe is grazing. So these kind of problems may come if your problem is not fixed, your problem is not narrowed down. So how you can going to detect the bad rules? So bad rules, if you wanted to detect, then you have to find out the following rules, like four signs of AI dooms. So what are the four sign of AI dooms? First, that problem is too hard. So don't take the problem that is too hard and that has broader dimensions. That the situation can occur a kind of that you cannot even imagine. Okay, like lions normally remain in a forest, but some people are even keeping them in a house also because they are their pets. So if you are training the machine with these kind of broader aspects, he may do the misclassifications. So how we can deal with that kind of problem? So you have to first warning sign, you have to notice that problem is very too hard, or there can be a different dimensions can also be possible, because in realistic scenario can be anything possible. Like right now we are developing driverless cars, but driverless car will also have a various kind of incidents in past, like this Elon Musk company Tesla trucks was introduced with AI, driverless AI, and the driver was sitting at the back seat and he was sleeping, and the driver and then truck was going on the track, and it was struck with the one car, and how it has not noticed that car, because that AI truck is recognizing the labels that is there at the roadside, which is going to give out the information about that. So the AI was understand that there is no person at this moment, and this is what the label is saying. So it has not recognized what is that there in the roadside also. So that kind of collisions may occur sometimes when we are not feeding the right rules to our machines. So a lot of incidents has happened. This is not a one or two cases. Many more cases are there. So warning sign number two is that problem is not what we thought it was. So at the end, when we do the machine training, and after keep on doing a lot of training, trial and error, still machine is not reaching out to its goal. Every time it is giving a kind of solution which is out of the context. Then you have to look at back and see whether my problem is correct and whether I'm solving the problem that is actually going to lead me to this goal. So that is the warning number two. You have to think of it at first. Then warning number three is that there is a sneaky shortcuts. So sometimes what happens, your data that you are feeding to a machine learning model, it is going to find out some sneaky shortcuts. And that shortcuts sometimes gives you the correct output. But you are not knowing whether it is doing actual computations with all set of features that you are providing with the data, or it has finding out some kind of shortcuts. So these are the pretty hard problems to find out whether the AI systems are taking only the sneaky shortcuts. Okay, so we have to find out those problems also. And how you can deal with these kind of problems, I'll tell you about the data information when we are going to explore. So kind of distributions are there through which you can understand whether the data has a skew or data has a left skew, right skew, or data has symmetry or asymmetry, or kind of distributions are there like binomial distribution, Poisson distributions. So we are going to experiment with it, and we are going to see how we are going to deal with these kind of problems. AI tried to learn from the flawed data. So as I say about that, AI models is basically depends on the past data, what you are going to feed, what you are going to take the data to train the machine. Like petrol is a fuel for IC engine, data is a fuel for AI machines. So if your fuel is not good, you are not going to get the better mileage. So you have to see what you are going to miss out in the data. So data inspection is a very, very important task in AI model development. And at the beginning itself, you should know about all the data components, what you are going to miss, what you are going to take. Okay, so this is what the way you have to look at all the different bad rules that you are initially, if you are not resolving with the data that you are going to feed to the model, that you are going to get a kind of results that you are not predicting that it is going to give you. Okay, so kind of problems that we have to deal. So if you can see here itself, I have given some set of informations and kind of problems where you can understand. It like starting with a kitchen full of ingredients and ending with cookie. This is what our target. And I have given a set of ingredients in a kitchen. Now robot goes into the kitchen and he is mixing some kind of ingredients and bringing out some kind of cookie. So what kind of steps it is going to take to follow up the right ingredients to be mixed up. Okay, so that is what the goal is there, problem is there, and we have data also. So this is what important. If ingredients is not correct, so you have put it in place of sugar, you have put it salt. A kind of problem may happen. So how much ingredients you have to mix it to make a proper dough for that cookie. So that is also a kind of intelligence that you have to train to your machine in order to come up with the right solutions. So that is what the rules that you are going to make by a machine depends on the data quality. Now let's come to the project cycle, because this is the today's agenda of our discussion. The past, whatever I've given, that basic background about the machine, how it learns, how it deal with the problems, and how it set its goals with the available data. So basically, this is a kind of model was proposed by the CRISP DM process in late 1990s, and it is most widely used model in machine-to-machine communication, machine-to-machine intelligence, data mining process, data science engineers. So this is what the standard model, most of the AI engineers uses, or data mining engineers, data science, or data, whatever the different roles you are seeing in the market today related to AI. These are the models they are going to adapt to make a AI system to be complete. So beginning process is with the business understanding. So business understanding means what is the problem in the business that you are going to solve through an AI. So like a client will come to you and he will say that this is what the problem I wanted to solve through AI, because it is consuming a lot of my resources if I'm giving to a human. Why can't I give this to the machine so that I can spare the task, my money also. So kind of way you have to come up at the understanding side, and at the beginning of the previous 2 or 3 slides I have given that understanding. You have to fix a goal, and that goal can be achieved by a machine. That kind of understanding you should grab it. Then data understanding is very much important, because this is a fuel to run your AI engine. So AI engine is needing that understanding. So in this context, we are going to discuss a lot. Once we have clarity about the data, then we can move on to the data preparation. And then finally, we can model it and then we can evaluate it. So evaluations and data understanding is basically giving you the information about evaluation also. If you have known about the data context, and what is going to give the data to us, then you can able to make the proper evaluation also at the end. And this process, if you can look at into the diagram itself, modeling may give you the wrong predictions, then you have to adjust your data preparation. So again, you have to look out at the data side. In evaluation phase, if you are not getting the correct predicted outcome after multiple trials, then you have to look back at the understanding side whether I missed out something from the problem domain. So that kind of process is repetitive. And business understanding to data understanding is a process that takes a lot of time. And if these two processes are correct, then data preparation, modeling, and evaluation will not take much time. Once you are complete it with all kind of understanding and your model is giving a correct results for the kind of problem, then you can deploy it into the real world. You can introduce like a product, Google Assistant is there, or like Alexa is there, kind of products. So what business understanding is basically talks about, you should come up with a clear view of business problem to be solved. So there are some of the problems I have mentioned. There you can even think of it in what context you have to narrow down a problem to a AI specific. So how might a price adjustment impact your sales? Like business problem is like when I'll be finding out my business product which I'm releasing in a market is not getting popularity. Then if I can reduce the price of that product, then how I can increase my sales. So kind of adjustment you can do it with the help of an AI. So AI will take all kind of surveys that is given by the customers while they have purchased the product. So feedback form is there. Sometimes you have seen on Amazon also you can give your feedbacks. So these feedbacks also machine learning is going to take and finding out what popularity the product has in the market. And kind of that predictions may give you the kind of understanding, okay, this is what I am missing out in my product launch, and my understanding in that context, I should improvise my product and then again I can relaunch it into the market. So kind of problems there you can look at. AI powered resume scanner to decide which candidate to interview. This is already in place in our real world. Now AI systems are taking the interviews and they are deciding whether the candidate is good or not good. But there are kind of problems with the AI systems at present because human is smart and human has only built that AI system. If he is a good actor of acting, then AI can also be fool. We can make it fool to AI system also. But this is what kind of repetitive task, and many times you can receive a lakhs of resumes. How you can analyze it and finding out the correct candidate for the position. So the AI system can do this task very effectively. He can look at its past experiences. He can look at its educational qualifications and what kind of skill set it has. So he can scan it from his resume and try to map it with the role that is offered by the industry, and he can fix it. Okay, this is what the kind of match, okay, we can take it at. Nowadays you have even seen the various kind of matrimonial sites also there. They are also mapping your attributes with the lady and finding out the good match. So kind of solutions are now already in place, and these are the AI powered. AI to decide who should be approved to a loan. This is kind of also a problem nowadays, and they are solving it through AI. They are seeing the past, any loan defaulter kind of thing is there with you, then they are not going to approve your loan. So they are going to see your salary slip. They are going to find out how much your monthly expenses are there and how much your saving is there. So based on that, they can also predict it and finding out, okay, we can approve the loan to this guy or not. depending on the context, depending on the kind of situations. But sometimes these AI predictions are not always be correct, because there might be a certain conditions, might be he faced certain kind of accident in his family, and because of that might be he is not regular in his job, and that kind of reason, because of that he is requesting for the loan, but he is also not having the past history of its salary and other things. So these are the problems where you can have auto tagging faces on photos. So like Facebook, when you upload the photos, automatic tagging is coming. So they can tag your photos. These kind of problems also, you can take it up. AI can look at hundreds and characteristics of phone customers who switched from different providers. So this problem we are going to see in a demo, and how is one particular person is going to switch to another subscriber, what kind of possibilities. So there is kind of data we have, and we are going to predict out of that. So we are going to take a supervised learning method, so we can provide some training data and some testing data. So training data, we can train a machine, and then we are providing a testing data to test it out whether is able to correctly identifying it or not. So that kind of demos. AI revolutionized image recognition and language translation. So this is what the two things we have already seen in market, like language translations, a chatbot are there, image recognition systems. So many things are we have seen in product wise, like Microsoft has launched a lot. Apple also introduced in their smartphones. Decide whether problem actually needs an AI help. So this is what the major problem. People are not able to understand at the beginning itself whether the problem is for AI or we can solve it with the normal traditional programming methods. So this is important. So you have to find out whether the solve problem is really hard, and the human cannot solve it in fastest way. Like a computer can process information at much fastest way, so he can process a millions of records in a second, but human will take a long time to process those kind of tasks. Like I have given the example for finding out the appropriate candidate for the job interviews, that is kind of repetitive task, and lakhs of resumes I cannot analyze and I can find it out the best candidate. So in that case we can choose an AI and give that problem to that. So you can find out what problem you are going to deal with an AI. Now let's come to the important topic, because this is what the fuel for the AI engine, and we are going to provide this fuel. Based on that, it is going to give us the results. So in this step, we look at the data sources and data exploration for a project. And this is what the important step. If we missed out this step, definitely your prediction always be going to give you the surprising results. So the data sources from where you can get the data. So in coming days, we are talking a lot about the big data. We are talking about IoT. We are talking about census network, smart intelligent, smart city, smart transportation system. So wherever you see a smart things, there are set of sensors are embedded into the device, and they are going to generate a data. So data source can be anything. You can have your own smart home related data that you can use it for train your AI systems. So data can come from websites. So you can even get it the data from the government organizational websites. They have a long statistical information about the kind of data. Like every 5 years or 10 years, they do the population counting. So that kind of data you can also get it. How many voters have given the votes? How many voters are eligible to give a vote? Kind of data you can get it from the organizational website. Some of the data you can get it open source, so that you can freely get it from the on the persons. But only the problem is that with the open source data, we are not knowing what kind of features the data has, what kind of vectors it has, whether the data has the required features for my problem, or what kind of cleaning and what kind of modification I have to do with the data. That is what the problem comes from the non-standardized data. But always when you are going to build that kind of AI model, you have to pass on with this particular step, data understanding. So open source data, you can get it from government organizational or scientific institutes. They are going to release kind of data. In present pandemic situations, also we have a COVID patient data. So that is also kind of data you can use it and predict it in future. If we can have the kind of strategy, social distancing is not maintained, then how much possibility of increasing in the cases, whether we are going to encounter the third phase of COVID. So kind of predictions you can make it with these kind of available data. Third party data is more difficult to get from the people. Like in hospital, you are going and approaching to a doctors and the administration of that hospital, please provide me the eye data set of the person so that I can find out the cataract disease possibilities in the newer patients, if some kind of features I can extract from the eye. So these kind of data set you can get it from the kind of places, but that is also a kind of difficult, because for that you have to write an agreement, you have to visit a uh, notary office and take a notary, and then you can cite put it all those things. That is kind of difficult process, and sometimes third party data is not directly available for us. Data exploration side we have to look upon. So these are the sources from where you can get the data. And one more open source is available on internet, that is Kaggle. So through Kaggle you can get a lot of data sets publicly available, and you can use it for your model training purposes. And most of the data set I have also taken from Kaggle. So while I'll show you the demo, I can show you this is the website from where you can get. So what is the data exploration? So what is there in the data? That is what our requirement. So once there is a team of people who are building a AI system, and you encounter that one person is dedicatedly allocated for collecting the data from the different sources. So he has collected the data and put it onto your desk. So all yours. This all data is yours. Now you can play around with it. Now, the next person is going to analyze the data. So the basic summary of data, first we have to analyze what is data is going to give us. So kind of data is going to give us, like we can directly see about the average values. So what is the arithmetic mean about the data? So if there is a numeric data, we can calculate kind of informations like arithmetic mean. Then we can have a median. So we can also look the median of the data. So we can arrange the data from in ascending order and find out the middle of the particular element. So mean, median, these are the important aspects. Sometimes they can also give you a kind of informations which is helpful for evaluating your model. So mean value is basically arithmetic mean. So summation of all numbers divided by number of elements. You're going to get arithmetic mean. So if I'm taking a mean and median of my data, both are different. So mean can be changed if, let's say an example, a boss salary is doubled. So other employees' salaries remain same. So if boss salary is incremented by twice, then mean will change. So overall salary of the company for the employees will change. So mean value can change, but the median can be at the same place. So there is a difference. So mean and median will give you kind of difference. Similarly, mode is also there. So mode is basically give you the information about the most frequent data elements. And this is also very much important because most of the machine learning algorithms finding out the patterns in the data. So mode will help it out. But it is not like that all the data that you have collected will have only a single mode. There can be of different modes. So mode is most frequent data. And mode is also gives you the information about the mean. If mean is going to change in your data set, then mode will also be at the near to the median. So there is a kind of difference will come. This difference is basically going to tell us about the data, whether it is symmetric data or data has a skew problem. So skew problem I'll be going to discuss. First, the mode is important. So mode example, if I can give you like a camel. camel has a one hump. One hump kind of camel is there. Two hump camel is also there. So there is a pattern in this two data. So if I'm doing a camel classification, if I can show a picture of camel, so the picture can be detected by my model that this camel is what one hump kind of camel, and this has a two hump kind of camel. So there is a two mode in the data set. So that is why when you have a data, you should explore the basic summary of data by analyzing the mean, median mode. Another component about the data exploration is variance. So variance is going to give you the information about the data spread, how far it is from the median, how closer it is to the median. So if your data spread is too high, then it means the variance is too high. If your variance is low, then your data spread is also low. And this is also a kind of data exploration we have to do at the beginning. Then standard deviation is a same kind of like variance, and it is also give you the square distance from the mean. So they both are basically giving you the kind of information about the spread of data. So spread of data is also useful in some context. We wanted to see how spread the data. So if data is too much spread, there is a problem of kind symmetric and asymmetric. So these kind of problems I have represented with these graphs. So if symmetric data is there, then you can have a mean, median, and mode at the same place. So you can have a pattern of same kind in the data. So mode will tell you the most frequent occurrence of the data is like this. So that is the more suitable data for our machine learning because there is a high correlation between data. Okay. Median and mean is also there. So if I can take a mean of something, I can give a kind of predictions. But sometimes when you get the data from the data providers, you will find out that there is a right skew and a left skew, or positive skew or negative skew. So in positive and negative skew means the median is there, but your mean is going this side and mode is going this side, a kind of positive skew. So these skew problems will give you a problem like when you train your machines, this set of data, if you are going to give only this set of data, then the prediction is something different. And if this side of data you are going to give, then predictions kind of different. So it is always be advisable that we should first make a data to be symmetric. So how we can going to make that? I can add some numbers. So mean value can shift it to the median side, and mode can also be a little bit to there. So in that case, I can make my data symmetric. So sometimes data augmentation will do, and to make the data in a normal curve like this, like a symmetric curve. And most of the time, we will be needing a kind of visualizing the data. So visualization context comes when we have a data that is huge in quantity. And by analyzing it in numeric way, it's not advisable, then we can look at the visualization topic. Likewise, in the negative skew also we have a problem. So here also we can do kind of data augmentations and bringing out the data in the correct forms, like a symmetrical distributions. So, but if you can see practically, some kind of data will not have that kind of symmetry. If I can say about person heights, so there are some people are taller, some people are shorter. But if I can make them collectively, there kind of some symmetry can come. So there may be a some kind of, if shorter peoples are more and taller peoples are lesser, then also you can face a skew problem. So in that case, whenever the data set will have a skew, you should always try to jumble the data. You should not always give the one kind of skew data to a machine because it is a kind of biasing problem. You are biased to that particular data to that particular machine. So machine will bias, and whenever it biased, then you are going to get all the time correct prediction, or sometime all the time you are going to get the wrong prediction. So randomization we have to do the data, so that mixed category of data goes for training purpose, mixed category of data goes for the testing purpose. Another important aspect that we have to look at into the data, that is a correlations. So Before I can go about this correlation, let me discuss about this. So if you are interested to look at into these data points like mean, median, mode, that is a basic summary, then we have a kind of distributions. And these distributions are more popular nowadays. And we need not to do the numericals in our copy and papers. Nowadays, softwares are there to help you out what kind of distribution your data has. So kind of distributions we can have, they are very popular like normal distributions, binomial distributions, Poisson distributions. So what they are going to give us. So let's see with a small demo. So I have this R platform. So R is a programming studio through which I can have these kind of exploration on the data. And it is going to give me a lot of informations. These kind of things you can even do it with Python programming. So no need to just go to the R Studio or the Anaconda framework for making the machine learning models. You can do these things in Python itself in more easier way. And Anaconda framework is basically giving you the Python sets. So let's see, first we can draw normal distributions. And what is the core component in this, I'll be going to show you. So when I'll plot this data, so you can going to see a kind of data. So if you can see, I have plotted 100 points. There is a mean will be 0 and standard deviation is 1. So when I get the data, I'll explore the normal distribution curve of this data. And if I can find out any of the data point which is going more than 2 standard deviation away, then my data will have the unusual component. I should do something with that data. So this is what the data I plotted. In this also you are going to see a kind of distribution where one or two element will be more than two. So if you can see, this is an unusual component. So data science engineers always see kind of things where you can have the unusual component. This is also 2.3 standard deviation away from the mean. So this is unusual component. You have to notice out when you have the data. And you are seeing that the data has a normal distribution. So these are the important component. Sometimes you will also find out the normal distribution more than two, like three. So hardly you can see in this, but sometimes in the data you can get these unusual numbers also. So make a note of it that if the data will have the high variance, it means the spread of data is too much. So this spread of data is not a good, because it is going to lead you to the towards the skew problems. Okay. So now I'll go to the binomial distribution. So binomial distribution is also very much popular, and some set of problems you are going to see where binomial distributions are going to play a major role. Like when I'm tossing a coin. So let's say this many times I've tossed a coin, how many times I get the head. Kind of problems you will face in AI also, where data set will have a binomial distributions. So when you have these kind of data, you also analyze whether the data skew problem is going to occur or not. So if you can see here, I'm tossing a coin 30 times and I'll be having a probability half. Then what kind of distribution I'll be going to get? So if your data set will have kind of this. So if you are seeing here head, then tail, 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 then head, tail. Sometimes when your distribution is going to be analyzed with binomial distribution, you are going to see 0, 0, 0, 0, 0, then followed by 1, 1, 1, 1. These kind of data is basically having a problem of asymmetric distribution, or skew problem will be there. So whenever you see kind of data which is biasing, when you apply the to your model, kind of data where tail is coming up, and this is what the portion you have taken for training your data, training your model. In that case, your prediction may be sometimes always be right, but this is not the correct way of giving a training to a model. You always have to randomize your data so that mix of data comes. So tail head should come. Then your mix of data is kind of data you have to give to your machine. Poisson distribution is the most popular one in machine learning algorithms, because kind of problems you are going to see a lot many problems fall under the Poisson distribution. So Poisson distribution basically say the occurrence of event, how many event occurs in a particular time interval. So a kind of problem I can give you like here the problem is like in a 1 minute how many customers visiting a ATM, a kind of informations bankers are looking for to deploy more number of ATMs in a particular place. So they are looking at the statistical report or distribution of the number of people. So how much crowd is coming to that place. So they can place it more number of ATM in that locality. So here I have taken the four customers are coming in average. So in 30 minutes, how many customers are going to come? So if I can plot this Poisson distributions, you are going to see, let's say in 1 minute, 4% coming, then next minute, three, then two, then five, then seven. This is what the kind of distribution. So in this kind of distribution also, sometimes you can get the 4, 4, 4, 4, 3, 3, 3, 3. So these kind of problems you have to avoid. So while you give the model the kind of data, you should always think of it whether data has any skew problem or not. And this is what the Poisson distribution is most popular one. So kind of problems you can get if you are not having that data set, you can even use this Poisson distribution to generate your false data, and you can train your machine and find it out whether the machine is predicting what I am expecting from the machine. So false C data, you can create it with this Poisson distribution and need not to wait for the data. Once the data comes, your model by that time ready to test it out. So that is what the benefit of Poisson distribution. So any event occurrence kind of problem you can solve it with Poisson distribution. Like in a junction, how many cars are crossing in a junction? So I can scale up my road network. So that kind of analysis I can also do it with the Poisson distribution. So now if you can see, analyzing this data numerically is a time taking, and lot of time it is taking in order to understand what is the data is all about, what is the data is containing the informations. Okay, so this is not a good idea to lead us into a right directions. So what could be the best way we can have it? We can do the virtual visualization of this data. So visualization kind of we have various kind of tools that you even can do it in Python, like histogram plots. So if I can plot the data through histogram, I can visualize more set of data. So like if you can see, this is a histogram. So I'm basically plotting this data. So if you can see in histogram plot, we have a bins. So within the bins, you can have the informations like 10 to 15. I have divided my data within that bins. So within that bins, I have the segment of information. Other will have this. So this histogram is representing the car. Those are fuel efficient, and over a year, these cars are modified for more fuel efficient. So if you can see 15 to 20, you have seen a car, they are not quite a good in fuel efficiency kind. But when you can see, look forward 25 to 30, you have a car, they are very much fuel efficient. So we have evolved our machines in such a way that they're going to keep us into the higher efficient car. So this is what kind of representation where you can visualize your data in a small bins and see a lot of informations through visualization. Because numerically, if you can see the data is given in tables, analyzing it, it's a kind of difficult. But analyzing the data through kind of graphs will give you a lot of informations. So this bins, I can adjust it according to my requirement. Sometimes I even use the bin size 5. And this is also going to give me a lot of informations. So if you can see, previously my bins was 10 to 20 or something likewise. Now I have reduced it to 5 to 10. So in 5 to 10, there is no car. So might be the data is missing in my data. But this is also a kind of problem. Through visualization, you can get the informations. So how much data is there, what is the outline of my data, what is the inline my data. So this is what the informations. You can also gather it from the visualizations. Now let's look at the other aspects about data. Like we have a even smaller than bins. Like 5 is not advisable for me. I want it even lower than that bins. Then we have a density graph. It will give you a kind of line kind of graph. So for the same, creating this data. So the same fuel efficient car, now you can easily visualize in the line kind of graph. And you can notice that from the 15 to 10, the cars are not very fuel efficient. But when you can see when we approaches to the year of evaluation, evolving, and we are going to get a very good kind of graph. So with this graph, you can also understand the fuel efficiency has increased over this particular time segment. And by that time, it is keep on going to be down and down and down. And now we are not using any kind of fuel cars. We are going to enter it into the electric e-vehicles. So kind of justifications, you can get it, or kind of storytelling, you can simply represent it with the graphs. In the same kind of representation, we also have a box type graph. So this is a box type graph. Most of the time, financial peoples use this. In the stock markets, this kind of graphs is also very much useful. So box type graph is going to give you a kind of informations which has a basic summary of data also. Like this black line is basically representing your median. This is representing your, sorry, mean value. And above the mean value, you have a second quartile, and below this, you have a first quartile. And this quartile is basically giving us the information. If this mean is going upside this side, then 25% of data is upside and 75% is data downside. Kind of information you can get it from the data. So if this is a mean at the middle, then 50% of data is in above the first quartile and second quartile, 50% down to the quartile. And this is what the top one, that is going to give you the min and max value. So this is called whisker. So top of the mean, this is a maximum value. This is what the minimum value. So kind of informations you can analyze through visualizations, where you can have different varieties of plots. And box plot is one among that, that gives you a kind of information which is huge in number. And by visualizing it with a graph is much easier way. In the same segment, we also have a kind of plot, like we have a kind of plot in scatter plot. So, but we have also a bar plot. So bar plot I'll show you. So bar plot is different from the histogram plot. So if you can see, this is a bar plot. So here I'm not creating any bins. If there is some range between this to this is what the graph. Between this to this is the graph. Then this is kind of histogram plot. But this is a bar chart, a bar graph. So here if you can see, a number of gears increases in the cars over a year. So initially it was 3, then 4, then 5, now introduced. So kind of understanding you can get it from the histogram plots also. So this is also kind of representation of your data, which gives you a lot more informations that if you can see in tabular data, kind of difficulty, or even you can miss out some of the data points. So visualization is giving you that benefit. Sometimes visualization also gives you the informations about the type of model is more suitable for that kind of data. So if I can see scatter plot, so scatter plot, if you can see here, some kind of linearity is there in the data. So data increment is linearly towards the approaching side. This is in the positive side. So some kind of linearity. If I can use a linear regression model or logistic regression model, I can make out the better prediction in future, what could be the next predictions. So imagine a case like my monthly electric bill uses, my monthly electric uses that much unit, so I should get this much bill every month. But suddenly your bill is going to get higher. So there might be a slight increment of your units in the coming months. So depending on season, some hot season is there, then you are operating AC. So your reading will go high. So accordingly, the linear relation between the attributes are there. So kind of linear relation, if you can find out between the data points, then the models are also appropriately available. That is linear or regression model. You can apply to that kind of data and train your machines. So this is what the benefit of visualizing the data tabular form or in the graphical form. So this is kind of scatter plot. And one more plot is there which gives you a kind of informations like a heat map plot. So heat map plot is going to give you the kind of distribution where you can have heat map images. So this is what the heat map image. So in this, this is a diamond heat map image. So diamond based on the carat. So there is a different color representing the different carat of the diamond, and accordingly x and y values are there. What is the texture on the uh, diamond? What is the clarity of diamond? What is the cuts on the diamond? So kind of different attributes related to diamond, and based on that you have a kind of price also. So this is a kind of color map distribution, or you can see a heat map distribution. Most of the cases you will be seeing these kind of heat map images when you do the classification of thermal images. So sometimes in medical diagnosis, you will get the thermal images. Sometimes you can get CT scan images. So these images will have kind of heat map kind of distributions. So some colored images, MRI images you can get. So there you can do some kind of predictions. Some tumor detection. So the scattering of tumor color will be different. In most of the medical kind of diagnosis, we have spectrometers to analyze the kind of protein inside that cell, like in cancer cell or in tumor cell. So that kind of give you the color kind of graphs. And based on that data also, if you can able to train your model, he can classify the correct color corresponding to that particular tissue or that particular problem. So this is all about the different types of distributions, different types of color representation related to data. So very, very important. Then we also have to look on the data correlation. So correlation means when you have a data segment, like I can give you an idea about this. Like I have a patient data. I wanted to predict whether he can have a diabetic or he is a non-diabetic. So I have his age, I have his daily glucose level. Now I'll be monitoring its glucose level daily and finding out whether he may be going towards the diabetic range, or he is in the boundary range, or he is below to that boundary range. So we wanted to find out in the data set what are the attributes are very, very close to each other, or they are making any kind of sense. Means if I have a data set and my model is going to predict whether he is going to get a diabetic or not, so what is the role of platelet counts in the data set? That is not going to make any sense. Or maybe other components in the data set, they has no relation with the diabetic predictions. So I should not use those data sets, because sorry, those attributes, because they are going to make my classification model to predict the correct results. They are going to create a problem. So I should neglect those attributes. I should only keep the attributes which has high correlations to each other. Like in linear regression, we have shown, like my daily uses of meter bill is this. So I should pay this much amount. So kind of linearity is there in this. And kind of problems you can see in daily world also, there is a linearity in that. So that kind of problem will have close correlation between the attributes. Here also in the data set, you will find out the close correlations. And this close correlation basically represented with the correlation coefficient, and the most important one is the Pearson correlation. So linear regression also uses the Pearson correlation coefficient. So this is what is represented with the formula. With between this range, the data point will be like -1 to 1. You can have the three different kind of graphs that will give you the correlation between the data points. So if you have a numeric data set, you can simply apply and find out what correlation they have. Like one indicate the strong positive relationship, Like I have given the example for the meter bill and that number of unit based money, or kind of problem like you have a number of shoe available and each shoe has a different size. Like my foot size is 7, so I can have the appropriate shoes. So there is a correlation between them. Kind of correlation you have to find out in the data also. So that kind of attribute you can select it for your machine training purposes. You also see negative indication of strong negative relationship. So what is that correlation coefficient tells about? So there is a adverse effect of one is going to change the other. So if I will talk about the positive relationship, so if correlation coefficient 1 means every positive increase in one variable, there is a positive increase in the fixed proportion to other also. Like meter unit related to the price, they are also going to increment. But if I can say -1 coefficient, so every increment of one is going to decrement by the same proportion to other attributes. Like you can have uh, in your cylinder, the gas is there. So how rapidly you are consuming the gas, so that fast it is going to get empty. A kind of relationship where you can have a relation between the speed and a relation of the decrement. So these kind of correlation coefficient you can find out. And this correlation coefficient is very much useful in our data science or in AI machine learning, because sometimes we need to reduce the dimensionality of the data set. Dimensionality means there are various kind of attributes. If I can take all the attributes to train my machine may get confused which attribute should be right, which attribute should be wrong, and all the time it will not able to make a correct decisions and correct results, which is leading towards the goal. So I should take the appropriate decisions. Let's say I have find out three attributes are very close correlated. So I should train with these three correlated attributes to my machine. But there are other attributes, they are not making any sense to my data. I can simply reject them. And with these three attributes which I have selected, I can generate three more extra. Okay, because there are certain proportions of increment and decrement. So if one increment, then linearity is there in the data. So kind of correlations you can calculate. And the most important correlation coefficient is a Pearson one, but you can also have a kind of different correlation coefficient. So this is a statistical measures that you also have to look. Then data preparation comes. So data preparation means you have to prepare your data. You have to find out there is a duplicacy is there, outline is there, consistency is maintained or not, validation of rules are there or not. A kind of data which has all kind of informations, as I've discussed about from the data distribution point of view, correlation point of view. These are the all parameters that you have to consider in your data preparations. When you are going to train your machine, your data should be in correct forms. So binning I have discussed about that, how much range to range that much I should take, or whether data is making any kind of sense, like a relationship association rules, a kind of thing. So these are the different types of cleaning of data mechanisms. You can do it by seeing the data set, or you can also analyze the data from the numerically by seeing the distribution of the data. So previous one, the distribution of data gives you the data informations. Data preparation means you are selecting some set of attributes from the data and you are going to train your machine. So when I'm saying the data preparation means a kind of data that you get in the tabular form. Most of the time you can get the data in structured form, tables, or you can get Excel sheets, you can get in the database tables forms. So these kind of data are basically structured. So there are the labels to every elements. So you have a columns, the columns are going to give you the information about the attributes. Which what are the attributes? Like this is the age of the person, this is what the blood glucose of the person, this is what the platelet of the person. So likewise all the informations are kept, and this is what the field. So each row is basically going to give you the information about one particular entity, one particular person. So most of the time in machine learning you are going to encounter with the name like vector. So vector means the same, the column. Variable you can also see, that is also the same term. So vector, variable, and features and predictors all are basically the same thing. They are representing to a set of attributes that is there in your data elements. Now let's see some modeling we can do it and finding out what kind of relationship data can have. So we have an association rule, and association rule is mostly used in the recommender systems that you have seen on Amazon. Some kind of recommendation will be given to you when you are purchasing a one particular product. So this is a kind of mining technique, and this association rule is used in association rule based machine learning. So machine learning algorithms are there which will find out the close correlation between the data. So I can show you with a demo so that you can understand what is that association rule talks about. So association rule, I have taken one example over here. I have taken a data set of grocery. A person has visited to a supermarket and he is going to get the data related to it. He has monitored his purchase requirements. Whenever he goes to the supermarket, he analyzes that if I'm taking this, then the high possibility that I'm going to take this also. Like I'm purchasing a milk, then I'll be going to purchase a toast. A kind of relationship is there. Or if I'm purchasing a milk, then I need maybe tea also. I need coffee also. Kind of relationship you can find it out in the data. So he has created a data set where he has kept all the relationship which he has monitored, and based on that he has put it up some confidence level. So if I can show you here the some relationship between the data, the kind of data that is there, so you can understand. So data is wide in varieties like cream, cheese, and this is what the classification of data. This is a fresh data, uh, fresh category of data. Like vinegar is a processed data. So kind of processed data that comes in the packets, like fruits and vegetable kind of category data. So this is a data that is there in the tables. This is what the plain text data that you are going to get. So I can show you in this manner. So this is what the data that is available. So fruit segment is going to categorize with vegetables. So likewise the data is available in categories. Now we are going to see the confidence of the data, or we can find out the close correlation between them. So I have given the support and confidence that is given by default, and this is what going to make a rules. So if you can see, I have run this particular type of rules and confidence. So confidence means if this item is going to take, then definitely this is the item he is also going to take. So if I can show you the summary of this data, so you can find out the summary will have the basic summary of the data. So basic summary, min, median, max, and those elements are there. And if you can see, association rules are, there is a kind of relationship between the two elements. So they are of 84 size. There is a kind of relationship where the three elements are also there. So like if I'm purchasing a chicken, so I'll be going to get a chicken masala. I can go to take some other attributes also be part of it. Likewise, three relations are there, two relations are there. So two relation kind of this 84, three relations are 121. Now let's inspect the rules that we have applied on over the 10 elements only to check it out. See, this is what the result. The rules that is going to come up like if I'm going to take a detergent, then there is a kind of confidence that I'll be going to take milk and whole kind of items. This is a kind of two relations. Some of the relations you are going to see three also, like grapes I am going to take, then other vegetables also I am going to take. So this is also a two. So three is not there in this. So like I'll be going to take a meat, then I need to take some preparation for that meat, some vegetables. If I'm taking a frozen meals, then milk also I'll be going to take, because frozen milk always be kept into the fridges. So kind of association rules you are going to get out of it. So this is going to give us the informations about the kind of rules are there in between the data. So if you can see, three rules are there. So tropical fruits, other vegetables. So two rules going to link to the third one, vegetables. So kind of you are getting a lot more relationship between the data. So this is what the recommendation system is going to help you out when you are going to make a decision. So when you go online and purchase a new thing, they are going to recommend you the newer other things which is closely correlated with that. So they have a high confidence they are going to use for that purpose. Okay, like when we visit to see a kind of equipment, like I wanted to purchase some kind of, well, let's say washing machine I wanted to purchase. So numerous kind of washing machine it will represent to me, and it will give you the different types of price context also. But here is the actual business is going on with the association rule. If you can see, there is a sale on particular item. So if you are going to purchase that item, then there is a relation between this item to this item. So they are going to show you that item. So you are going to purchase the item on which the sale is there. Then you are going to need that item also because it is also has a close correlations. So for that they will hike the price. So that offer will be managed with that particular component. So ultimately you are not going to get any benefit. They are selling you the more product and they are not giving you any kind of offers. So this is what the whole drama happened in the online marketing. So wherever you can see, like Amazon is giving you at the lower cost, but it is going to grab your attention on the other items also. So if you can purchase those items, they tweak it to make it expensive. So one item they are selling in low, other item they automatically make you for you purpose, for you only they will make it higher. Another person it will be low. Kind of rules will be helping to them to make decisions. Okay. Now, in machine learning, a process is to create a model. So basically, this is kind of rules that is going to be used for a rule-based machine learning algorithms to train a model. And when you are going to create a model, then you require to data should be in order and it should be randomized because as I said, the data will have a skew problems. If data has a skew problems, then definitely you are going to have a wrong predictions. So choose the model. So there are two kind of models basically classified, supervised model and unsupervised model. So most of the time we are going to deal with the supervised model problems, but unsupervised problems are also there where your data is not labeled properly. Means there is a no specific information about the data or classifying to one particular attribute. So that kind of problems also you are going to face in coming future. But supervised learning is the most basic start point for a learner of AI. And we are going to see some of the models demo with supervised model. So to train a model, we basically divide a data into a two different segment. So training model, we can give as much data we wanted to give. So 70% data if I'm giving for training a model, then 30% I'll be keeping it for the testing purpose. Then I will evaluate the model. So whatever I have inspected in data information, data understanding side, that is a statical measure. So my data is I have provided to a model. Model has predicted some output, but it is going away to standard deviation from the mean. That is what kind of outliner. So kind of understanding from the data itself can help you out to make a decisions during the evaluation of model. So evaluation of model means 30% data you are providing and testing out whether it is giving a correct results or not. So it depends not only on the model design capabilities or learning capabilities, it is also depends on the what fuel you are inserting into the engine. So with the test data, you can see if algorithm is accurate or not. Then you can fine tune the model. So you can, if you find out that there is a certain mistakes, so some warnings I have given what is the AI dooms. So all those warnings you can please go through and learn it. These are the mistakes I think I have made it. I have think a problem which is not narrow, it is very broad. So kind of problem may come. Machine learning basically having a kind of different algorithms categorized in different categories. Supervised learning, we have a kind of algorithm where we have a labeled data and we can provide the training to a model with 70%, 30% data. We can keep it for testing purposes. Unsupervised learning, we don't have the labeled data. We have unlabeled data. So kind of models are also available for this. We have a clustering techniques. We can have a kind of k-mean techniques. So various clustering techniques are used for unsupervised learning, or even deep learning models are used for unsupervised learning to train the model so that it can also predict with the unlabeled data. Reinforced learning is also mostly used in the kind of computer games where the goal is set, and reinforced learning is kind of that we are not providing any training to anyone. Like if one child is seeing how I'm playing a chess game, so by seeing a multiple times, he is going to develop a cognitive skill. Okay, this is what the step he has followed to run this particular thing. Likewise, he can learn by seeing a repetitive trials, by seeing my particular way of playing the game, he can develop that particular idea. And then he will challenge me, okay, now I understood how you are playing, so I can also play with you. So reinforced learning, we will not having any kind of training and testing. He will learn by its own and then come up with the solutions. Semi-supervised learning is a kind of learning where the mix of these two learnings are there, supervised and unsupervised. And in this also you can have a kind of mixed category of data, sometimes labeled or sometimes unlabeled kind of data. So I'm not going to deep into these kind of classification, what are the algorithms are there. I'll directly jump off to the decision tree, and after that artificial neural network is there. So these two models I'll be going to discuss so that you can get clear picture about this. So decision tree is a model which mostly work with the non-numerical data. Very good in non-numerical kind of data where you are not having a numbers, you are having a labels like a true, false, or this is what the value. Sometimes numbers also be there in a kind of problems. So if you can see a decision tree is kind of a decision which I can make it by inspecting all possible outcomes. So possible outcomes like there are various problems, not a one particular problem. In our day-to-day life also we make a decisions. So based on our past experiences, we make the decisions, okay, this way if I go, I will be going to get the answer. So it is kind of divide and conquer strategy. We are taking a big problem and dividing it into a two different part and making our decisions. So dividing it. At the end, we are going to get our solution. So it is like a tree structure. You have a root problem and you have a solution at the leaf node. And in between that intermediate nodes, you are also making a decision. So this is a bigger problem divided into two. This problem again you are divided into two subproblems. And these two subproblems basically having a solution. So this data set is basically collected from the Sydney area in Australia. So their weather data is there and they are going to predict in the next day there is a possibility of rain is there or not. A kind of data where you have the all possible attributes, temperature, pressures, and other attributes. So they are checking out if the pressure is 84%, then the other parameters they are also analyzing it. So you can take this particular path to analyze further. If you have a pressure less than like 16%, then you can go to this particular path and analyze the possibility of rain. Then you are going to this side and you are analyzing other attributes. What is this? Is there cloud at 3 p.m. And less than 7.5 precipitation? Then you can predict, okay, yes, it is there. Then you are predicting that there is a 95% chances that rain can happen. And there is a 33% chances rain will not happen. Kind of discussion, kind of decisions you are making at every subpoint. So it is like a tree structure where you can split a big problem into a small problem and come up to a solution. And kind of problem you also see in day-to-day life or in the real environments also. Like you have a problem, you have a goal. To reach at that goal, you have to follow a different path. As I have given the example for reaching out from Chennai to Delhi, I have a different paths to reach out. So I can find out which one is the optimal one, which one is going to give me the better benefits on the journey side. So flight is the most optimal way to go to the Delhi in shortest time, but the price context is there. So I can find out other offers in the websites like go ivivo, sorry, other kind of platforms are there, like clear trip is there, make my trip is there, whether they are going to give me any kind of offers. I can scroll the data from the web frameworks and going to get the better information about the offers, and I can choose appropriately which is going to give me the better benefit and comfort for my journey. So this is what the kind of decisions. So I'll be going to show you a kind of decision making with one small decision tree. So here basically I'm having a data set where the various kind of subscribers are there, like Airtel subscribers are there, Idea subscribers are there, Geo subscribers are there. So their data set I'm having, and I have also the decision about the person or decision about the subscriber, whether he is going to, in coming days he can migrate from Geo to Airtel or Airtel to Geo. That kind of goal is there, means I have some kind of understanding about the subscriber. So I have that data. So I'll show you that data also, so you can get a clear picture about this. So this is a data set from the US. So their state code is there, and I have a data like it has a voice plan, it has no voice plan, like it has an international plan or not, a kind of data, how much time he is talking in a day, how many calls he's making, how much charge I'm taking out of it, and kind of different type of data is there. And at the end, if you can see, he's going to churn or not. So he's going to move from the from the Geo to Airtel or Airtel to Geo. This is what false and true if statement is given to me. So my goal is there, my data is there, my problem is there. Now I'll be going to make a decision. So I'll be going to train my machine so that 30%, 70% data I'll provide to test it out, or to train my machine to give me the better predictions. So if I can examine how many churns are there and how many not churns are there, so you can find it out that there are customers they are going to churn, that is 572, and 95 are not going to churn. So they are not going to shift from one subscriber to other, but 572 is going to subscribe, change the subscriber. So this is kind of data is there. Now, if I am going to train my machine, I wanted to randomize this data. I should not give only the false statement to my machine. Then it always be giving me the false results. So I should give the mixed kind of data where true and false is also there. So I'll check the proportion of this, and then I'll be making a randomization. So if you can see this sixth and seventh step, I'm randomizing it. And by doing this randomizations, what you are going to see. So this is what the percentage wise, what is the proportion of false, what is the proportion of true. That is what the same way it was shown over here. So I'm generating the randomization of this data. So I can able to see what is the mixed category of it. So examining the first row in the randomized data to be compared with the. So this is what the data that I have, that I'm going to randomize it. So I'll be randomizing it with this function. And if you can see, now data is not starting from 117, it is having 127 likewise. So if I can split now the data has a 677 rows in the data. If you can see here, 677 entries are there and 20 attributes are there, which I am going to use for training my machine. So I split my data. So 90% data I am going to give for training purpose. So I have given for 90%, and 10% I will be going to give for training purpose. So if you can see this data, how it look like. So this is what the training data. So training data will have the false statement 85%, true statement 14%. And testing data should also get the same. Otherwise, it is not the correct way. So see, there is a kind of close correlation. So here 85, here is 89, and here is 14, here is a 10. So kind of good correlation between the data. for training and testing purpose. Now I'll use my machine learning technique that is called decision tree making, and I'll be applying this particular data to train my model. So now let's train it. So it has trained the model, and now I'll be going to examine how it has created the tree. So I can show you the tree also. So this is what the data that I have getting, and my tree is prepared. So if you can see, the tree is prepared on this, like total daytime minutes. So how many daytime minute he has used. So if it is greater than 263, then I'll be checking out whether it has a mail plan or not. Yes, it has a mail plan, but he is not going to churn. Oh, sorry, he is going to churn. And if he has a no mail plan, then he is not going to churn. So this is what the way we can have the decision tree. If he has a total daytime less than 263.4, then I'll check it out other attributes like customer service call, how many times he has done. So if it is done greater than 3 times, then total daytime minute is less than 16.5, then he's going to churn or he's not going to churn. Kind of decision I have made it through my model, and this is going to give me the ultimate output. So what could be the output? So if I will be going to apply my 10% of data for testing out, I can find out how many times it has given me the correct result, how many times it has given me the wrong result. So this is what my confusion matrix. So if you can see, false, it has given 56 times. This is the correct prediction. But false positive, if you can see, 4 times it has misclassified. But in the true cases, it has not given any kind of the uh, true false statement, but it has correctly identified the true cases. So only the 4 time misclassification done by my model. This is what the confusion matrix going to give you the information. One more model is there, that is neural network model, and it is derived from the biological brain of our human beings. Like in our human body, we have millions of neurons in our body, and they are interconnected closely together. So these cells are basically transferring the information to the brain, and brain takes the decisions. So kind of biological inspired model we are going to mimic in our machines also. And in that we have a perception cell. So I'll take only 10 minutes, then I'll wind up this session. So allow me to do that. So perception layer is kind of cell. So perception is a one cell which has some set of inputs and which has some set of weights, and it takes the cumulative sum of all, and there is an activation function which is going to give you the output. Okay, so kind of input that you are going to feed to this kind of cell. So this is kind of one neuron. One neuron is this one in our body. Imagine like that. And that neuron cell I have created over here with machines. So this is called perceptor. So first part, perform a weighted sum of the input, then appropriate weight discovered during the training. So I will providing the input data, and this weight adjustment the machine learning algorithm will do, and then it will be going to give me the predicted output. So this is a one cell. I wanted to take multiple cells of it. So I'll be going to collect them in such a way that, so this is a one cell, this is a one cell, this is a one cell. So this one cell will have an input, it has a weight, it has activation function. Likewise, I can have hidden layers also. I can have output layers. So input and hidden layer is basically making your system more complex. And if there are more number of hidden layers, then we are entering into the deep learning model. If there is a less number of layers, then we are still in the machine learning or neural network architecture. But if deep learning models or convolutional neural networks basically having a lot many layers, lot many hidden layers. So if I wanted to make a complex systems, my hidden layers can be many more. So related to this, I have also prepared one demo. So I'll show you that also. So here I am using a neural network model, and it is going to predict the wine quality. Like in wine industry, you can have a different kind of wine samples, and there are certain set of group of peoples are there. They are classifying the bad wine, they are classifying the good wine, they are classifying the category of wines. So kind of data set I have acquired from the Kaggle, and I'll be going to use this data set to train my particular model. So this data I have entered into the wines, and this wines will give me the what are the attributes are there. So if I can show you my data set, will have labels, will have the alcohol of this much, it has a malic acid, it has ash, alkalinity ash. So kind of component that is mixed into the alcohol to make the alcohol flavors of different types. Okay, so in this, if you can see, this is a data type where I'm not getting any kind of uh, goals. This is a completely raw data where I have information about the every attributes, but here is no like decision like yes, no, or category is also not given. Like what category this wine, what category this wine. So I'll be going to create some categories for the wines, and I'll classify the wine quality based on that their labels. So let's look at into this. So first I'll be going to find out what is their max min, and then I will scale up this data and I'll normalize this data. So normalization is a very important aspect in neural network, because bigger weights if your neural network will get, then the problem will happen, because the difference between the lower value and the upper value will become more. So we need to normalize the data. Once we normalize the data, the scaled value will be look like this.
Yeah, Dr. Munesh,
Yes, yes sir.
actually, sorry to interrupt. Actually,
Yes,
we
yes.
are going out of time. Hmm.
Okay, okay sir.
You have another session also. You can continue with the same, no
Mhm.
issue, along with the other topic. Because the participant will also join the next session by 2. So
Okay, okay.
you can conclude by 1:30 with question
Okay, okay.
answers.
Okay, 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 sir. Sure,
Okay.
sir, sure. Okay, then what I'm doing over here, I'm going to classify my labels. So I'll be going to add some labels into the data, so that when I'll taste the wine, I can classify them into a different labels. So the labels I've added into the data set. So if you can see label 1, label 2, label 3. So likewise 1000, if this is a label 1 kind of wine, and I can have kind of other labels like in the this particular column you see 1, and this column becomes 0, and likewise in the third column you will also get 111, others will be 0. So kind of labels I can create to classify the quality of the wine. Now I'll be splitting my data, as this is a supervised learning method. So I can show you the training data and testing data. So this is what my testing data, this is what my training data. So I have created a randomization, so that is why you can see the indexes are also different. Here also you are seeing that indexes are different. So after this randomizations, I will be going to get the training data. So I can just put that into the formula. So later on, you can see the neural network is basically getting created. So this is what my neural network is created after I have inserted my training data into this. So all the attributes like alcohol, phenolic acid, whatever the elements are there, and it has the 3 hidden layers that I have created. So these 3 hidden layers I have added into the program itself, like 13, 10, and 3. So the weight adjustment will start happening. So initially, when I will be giving the input, it will be not going to give me the correct classification. So what it will do, it will go the back propagation and do the weight adjustment at the hidden layers. And once the weight adjustment is getting in stable mode, it is going to give me the correct classifications every time. So if I can show you the particular confusion matrix for this, I have applied the training data. Now I'll be applying the testing data and finding out what is the actual and what is the predicted one. So if you can see, this is the actual and this is the predicted. So actual and predicted is going 5 times. It is giving me the correct classification. and other time it is not giving me any false result. So this is what my correct prediction I have made it for one category of wine. In second category of wine, if you can see, it is giving me 5 times correct classification, but one time it is giving the misclassification because he is categorizing my wine to the third category also. Likewise, in third category wine, if you can see, actual is and predicted is correct, but not correct at all. In sixth time it is giving correct, but one time it is giving not corrected form. So this is what the issue. So mean value, the accuracy is 88% I'm getting with this wine data. So at 88 time my prediction is getting correct, but rest of the time it is not going to give me the correct. So I need to add more number of layers to make more intelligent systems. So as many layers you can add, my neural network will start remembering the things, remembering the right category of the wines. So with this, I'll conclude the today's session. Thank you very much. Now I'll be open to discuss with you what is your queries. Thank you. Sorry
Yeah,
for taking
participants, you
more
have
time.
any query you can ask now to Dr. Singh.
Yes.
Dr. Singh, there are some questions in the chat box. You can please see that.
Okay, sir.
Hello.
Yeah, Vidyalakshmi, please.
Okay. So
Yes, sir. See, for 11th, 12th standard students, we are teaching them Python,
yes, yes, yes.
pandas, matplotlib and all. Okay, basic. So
Correct.
how this R, you taught us R now, one language called R.
No, I
How
have just
how it
no. I have
how
just
it
shown you
a
the.
demonstration? Fine.
Okay.
So how these are different, like Python and R?
Hmm. No, both are same basically, but R will have the statistical tools. So R will give you the data visualization, data distribution. Very effectively, you can do it with R. But Python, other frameworks are going to give you the other features also. So Python for the static point is the great tool, and you can use that one. And start with the supervised learning at the basic level. Not build a kind of AI system which is problematic. Take a very very small kind of problem. If I can give you the problem like knock knock is a game. So if somebody knock knock on my door, then AI system will reply back with some funny jokes. A kind of AI you can create it, that is very simple, very easy, and will not require a large data set also. So I suggest don't use the R, use Python basic programming and begin with that.
Excuse me, sir. Can you
Yes.
explain four confusion matrix parameters? Like it's showing 56407. What actually it is representing? Like 56, I know that when the result is false and machine is predicting false, then it is 56. And what is value 4, 0, and 7 for?
This is what you are talking about. Okay, sorry.
I'm talking about confusion matrix, sir.
So confusion matrix will give you the difference between the actual and predicted one.
Can you
So
share your screen or that slide so that we can discuss?
yeah, yeah, sure, sure. Okay, this one you are talking about. Okay, it is not present. Okay,
Not this one, sir. At the time of decision tree, you told confusion matrix.
okay, okay. Let me run this whole code. Okay, this one. Okay. So in this, like how many customers are going to churn? That is what. So this is what the actual. This is what the statement and predicted is what this one. So 56 time it is giving me the correct result. 56 customers are going to churn, and 4 customers are not going to churn. A kind of false positive. So it is giving me the correct only 56 customer purposes, but 4 customer it is giving me the wrong. This is what the wrong result, wrong prediction. This is the correct prediction. And if you can see here, it is 0. If it is here also 0, then my machine is giving me the correct results. I must say this is also be the 0. So if you can see diagonally, if all the zeros are there, then your actual and predicted are good, and your machine is going to be giving you the good results. That is what all idea about this.
Any
Sir,
other
the
questions?
projects that you showed, is
Okay.
it something related to data science, data analysis, and all?
Yeah, it is kind of that only, but data science and machine learning all are basically the same area, and there is not much difference in between them. So machine learning models
So
are
how,
there. Mhm.
so how will I start this with the school students, sir?
I must say you should start with the basic programming of Python. If you have
Python,
that idea,
everybody
every,
knows, sir. Python.
okay,
12th standard
okay,
student
okay,
knows.
okay.
So how to?
Then you can refer this website Kaggle. This is a Kaggle website where you can have the all basic understanding courses also. You can take a look on Python. If basic knowledge you have, then you can go with the machine learning introductions and data visualization, data cleaning, and all these information also there. Beside that, you are also having a data sets. So I have taken this telephone churn data from here, and I've
Okay.
downloaded it and I've imported in my R programming framework, and I computed it. The same data set you can use it in Anaconda or Python framework, and you can use it. So a lot of libraries are there. This data set is in CSV format, so you can download it from here. And the data, once you download it, you will be going to see look like this data. So data will have the all attributes like area codes according. So all this data you can represent in Python programming also. The same I have implemented with
Yes,
R.
using data frames.
Yes,
Data.
exactly, exactly.
Okay. Okay.
And
Then, so
then
importing CSV file into data frames, and
correct,
using that we can apply some statistics
correct.
functions
Yes,
and
correct.
show that in a graph.
Correct. Exactly the same. What I did in the R, the same you can do it in Python, and very simple way you can do it. So it is not very hard. And rest, I have told you about the data cleaning and other process. You can remove the sum of columns, some of the attributes, which is not at all in use, and you can create the dimensionality reduction of your data set. So once you apply to model, it will be going to give you the correct results. So model preparation is also not required in Python. All the models are given with one function name. You can call them and you can have the prediction outcome. So that you can share with your students also. So
Sir,
start with very basic.
Instead of Python, do you have any block coding sites? Just drag and drop and create some apps, AI apps, something like that. Or we
Yeah,
have to learn Python compulsory to do a project, like
but
for
Python,
each standard and all. And
no, basic Python you can learn it, and the basic Python framework are also there in the Python. Like scikit-learn library is there. For that, you can refer IIT Madras, IIT Mumbai one. They have created in Python very easy way how you can learn it. So that is there. I can show you if I can possible. IIT. So scikit-learn is this. From there also you can learn the basic things. Okay, I think might be some problem. But lot many resources you can get it over the internet. It is not like you have to fix it. I think they have blocked this particular portal at the time. But you can go to this one and you can get the scikit-learn library informations very easily.
thank you, sir.
And this is for the research point of view. For the school level, I'll always recommend you start with a linear regression, very simple model, which give you the kind of understanding to your students also, and you can also learn about a thought. So first you can find out the linear relationship between the data. That linear data, if you have, then linear regression is very simple model. Only line you have to fit on the data, scatter plot. Then you can predict the next outcome very easily. So that should be the starting point of the supervised learning. Linear regression, logistic regression. Then you can move on to the artificial intelligence, the one layer artificial neural network you can create that will give you only yes or no answers. Like I can give you example, like I have a set of burgers, 5 to 6 burgers are there. So I also have a review about the customers. They have given the review, this burger is very tasty. Now you can train your artificial neural network model, that is single layer model, which will say yes or no. This is delicious, yes. This is not delicious, no. That kind of small experiment you can do it. So very easy. So I think I have taken a lot of time. But these are the areas where the
Any other queries, participants you have? Okay, thank you, Dr. Singh, for giving your valuable time. And it is very informative. Lot of things you have discussed. Constraint only I stopped you.
yeah, no problem, sir.
So in the next session, which you have tomorrow, I can continue with that.
Yeah, I can give you some information about robotic things there
Yes, yes.
itself also.
Actually, in my session also, I'll be adding some robotics part.
Okay, okay.
Some
So
people are
I'll
asking.
I'll cover in the human computer interaction based.
Yes, yes.
Okay,
That I can talk.
okay, sir. Yes, sure.
That is how to develop a basic robotics project.
Mhm. Correct, sir. So,
Okay. Thank you so much for joining.
thank you, sir. Thank you all the participants for listening me patiently. Thank you very much. Thank you.
Thank you, sir. Thank you.
Yeah.